I went to Instagram some days ago to create myself a new account. I put the username, it was taken. I modified it and it was still taken. Well, it was very disheartening moment for me that my signature Sankit Dev username was already taken. But to be honest, it sparked a curiosity in me that how Instagram, which have more than 2 billion users, giving me instant feedback on username if it's available or not. Today I'm going to talk on detail about that topic in this video. But before we talk to the real solution of this, we'll go step by step like we go on DSA. We'll talk a naive approach, brute force, and then better, and then the real optimized one. Let's start with the first. So the first brute force solution that comes to every one of us is checking directly from the database. User types his name and I assume debouncing is implemented in the front end to reduce the API queries on each keystroke. And then API call is made to check the username from the database. And I also assume indexing is applied in database to make it faster. So is this a proper solution? Well, yes, if you are a company of 5 to 1000 users or 10,000 users. But if you are a serious company, you will run into a lot of issues. A single user checks more than 5 to 10 queries for his username. So multiply it by 1000 or 10,000 of users. Let's take an example. So there are two biggest reasons to avoid DB lookup. The first one is that connection pool of DB is limited. Let's say there are 100 active connection pool in your DB and each query takes 100 milliseconds. So let's calculate the throughput. The throughput will be 1000 queries per second. What is throughput? Throughput, imagine it like a pipe. So it gives us the total number of how much query our DB can process each second. So 10k queries it can easily handle. Simple as that. So what happens if any query come into our DB? It goes through a process. Each call go through a process. So let's say 10 people are typing Apple username at 10 different places. So DB will have to do the same thing again and again with each step only to know if Apple is available or not. So here let's see, it CPU parses the query and then it walks the B tree, and remember indexes makes things faster, but indexes are also stored on the disk, not on the RAM. So it's not that much faster, but it's faster. Like your whole collection is 1000 MB and the indexes reduce it to 5 MB. So that's why it's faster, because it only have to go through one single key. Now look at this number. If the number is small, 10,000 people making 5 queries, it's still 50,000 query. And then 50 lakh people making 5 queries, your DB will boom. Latency will increase, server timeout issues, everything will slow down. So the thing is, DB is not the tool, is not the right tool to be relied upon for this task. Second most important thing is DB is made for handling things like write, to handle complex tasks, not just doing same repetitive things, checking username. For that we have better options, which is known as cache. You can implement radius and all, but DB is not the thing for that. DB is a sacred place, treat it like a sacred place. Handle write queries, complex queries, but not read. For that, just implement cache, and that's what we are going to talk about in next point. Okay, can't we use hashmap? The time complexity of accessing any element in hashmap is O of 1. It's pretty fast. We can store the username in hashmap with, well, again the drawback is simple. The space complexity will grow linearly according to the number of usernames grow, which is bad at scale, especially the scale of Google, Instagram, Twitter and all. Apart from scaling, there are two more bigger reasons why Redis cache or hash map is not the right tool. First is you are storing data you don't need. For username check, what we need? We just need to know yes or no. But we are storing the whole username's string, and each string costs some memory. But in reality, what we store, session token, user profile, which we need temporarily. But in this username case, we're storing whole string into multiple just to check is this username available. It's just waste of memory. Second thing is that cache is not meant to store permanent data, and usernames are permanent. Once stored, always need to be stored, but cache is not meant to do that. Storing it in cache permanently defeats the whole purpose of Redis cache itself. That's why Redis cache or hashing is also not the proper tool to store usernames. Okay, so now we have already covered the two approaches, brute force and better. It's time to discuss the final solution, which is Bloom filters. I will explain it layer by layer so you understand it properly. So the first layer is imagine an array. Imagine any data type inside it. Layer 2. Now we replace everything with zeros inside it. That's called a bit array. Now the layer 3 is hashing. We create a hash function, and whenever a new username comes, that goes through this hash function. A username comes and it goes through a hash functions, which output some indexes like 2, 3, 5 random indexes, and the same username it comes again, it will generate same indexes. So the thing is, we take those indexes and flip the bits in our indexes to 0 to 1. For example, Apple username comes and the hash function returns 256. So we go into the array and we flip 0 to 1 at that indexes. So if again Apple comes, our Bloom filter will check the same indexes and it will see it's already 1 and output it's taken. Simple as that. There is a saying that in system design, there is no one correct answer. There is always a trade-off. And the trade-off here is that it can guarantee that a username is not taken, but it cannot guarantee that username is available. Let's understand with this example. So you remember that you type a name and you see this username is already taken. That is the false positive case. If it says that it's not available, it might be available because the hash indexes could have matched with that username as well. But the good thing is that if it's saying username is available, it's 100% sure that it's available. There's no false edge cases in that, and this is the reason Bloom filter is used for so many cases. Now the one last thing remaining is, let's implement Bloom filter, a small Bloom filter in JavaScript, and let's understand it one more step deeply. So it's time to implement the Bloom filter. So here, as you can see in the code, I have declared a bit array which is of size 10 for simplicity, and it's already filled with 0. And I have three hash functions here, and all are simple functions which is taking a string and doing some computation there. Let me explain a little bit about it. The first one is taking the string length, whatever we will pass. So if I will pass apple, its string length will be 5, and we're getting the remainder by dividing it by bit array's length, which is 10. Same in second hash functions, I'm taking the character code at 0th index character. So here character code returns the ASCII value of that character, and ASCII value is nothing but this chart. Just refer to this chart. ASCII value is coming from here. So if the first word is A, so its hex value, ASCII value will be 61. And third hash is also simple. I'm taking the character code of last element's last character and getting the remainder of the bit array. The point is, we have to keep the hash functions predictable. If I'm passing apple, then I should get the same result if I do it 10th time. If I have used mat.random or any other sort of stuff which might give result different, then it's not the correct hash function. So predictability is the one thing here. Now there are two more functions. I have hidden it just for the I don't want to confuse you and me also. So this is add function, and this is doing only one thing. It is adding those indexes which will get from hash function to the final bit array here. That function is responsible for that. You can see here we are taking all the indexes inside an array and then mapping over those indexes and flipping the bits of bit array to 1, whatever, simple. Now there is another function which just tells true or false. If I pass apple, then it just tell me if that apple string exists in my Bloom filter or not. Simple. Now just focus here. There's one will understand everything, and also I will show you the false positive case as well. So let's check. So here we have added two string. Let me zoom it a bit. So here we have added two strings, and that is cat and dog. Simple. If I check if cat contains or not, dog contains or not, then it should be giving me true. Let me just check node bloom.js, and as you can see, cat turned on three different hash functions, three different indexes, and dog turned on three different indexes. Now this one is the final indexes and it's returning true. That means if somebody wrote cat, it will return it already exists, so you cannot take that. But here you can see cow. Does cow exist? As far as our information, it does not exist. So cow should be available to take, but to my surprise, it's also taken. Here it's returning true. It means it's already in the array. How? So for that, let's look into the hash functions. As you can see, it's very simple thing. Cat and cow both have similar words. C, the first word, and W, the last word, and the length, all is 3, and the first and last character is also same. And if you look at the hash function, it will return the same indexes, and that's the reason it gave us the false positive. So there are many different things that we need to take care of. First, it's a very layman example. In larger system, this is not how it's used. In larger system, they use different hash function. They have to compute the k, I mean how many hash function they will need, and what should be the length of the array. That all should be calculated already. This example was enough to make us understand that false positive is there. And why there is false positive? Because there are previous text which would have turned on some indexes in the bit array, and the future word might match the previous username. Simple as that. But we don't use this in production system. So what do we use? And here comes the important part. Okay, so we already saw the limitation of these simple hash functions, but it was only to make us understand how collision can happen and all that. So and we also understood the false positive case, how it can be produced. And if there are low hash functions, the collision will be very fast. If the array is small, collision chances increases. Simple as that. So now there are some good hash functions like murmur hash. So it's a non-cryptographic hash function suitable for general hash based lookup and created by Austin Appleboy in 2008. There are many others also, but I will take example of murmur hash, and because it's also available as a node package, so it's easy for me to experiment and show it to you all. So now what I will do, I will install this, and let's talk a little bit about murmur hash as well. And I will use burn install murmur hash. Simple as that. Now, so there are three variants of murmur hash. I'm not sure if I'm spelling it correct, but yeah, murmur 1, murmur hash 2 and 3. So the third was it's the current version and completed in 2011. Well, it's too old. By the way, there are collision attacks possible in this too, as it's clearly written that a user can choose input data in such a way that to intentionally cause hash collision. So it's possible in everywhere. You can check out this GitHub repo as well, and this is installed. So murmur hash is installed and let's use it. Let's see how to use it. Okay, I can just import it. Simple const murmur hash required murmur, and then I will copy this. As we know, there are two variation, version 2 and version 3. So let's pass Apple and see why Apple. Let's pass my name Sankit and see what's the hash. Some seed value. Well, it's optional, so I won't touch it. Let's keep it 1. Let's pass only the username. Okay, let's run it. Burn final.js. Well, we didn't console, so my mistake. Console.log. Let's wrap it inside the console.log so we can finally see the output of this. Console.log. Okay, see, this is the, okay, let me zoom as well. This is the hash from murmur hash and the version 2 and version 3. So the thing is, this is how things will be working in larger systems. They would have complex hash functions for them. Some they might be using murmur hash as well, who knows. So this is it. This is what I wanted to show here, and you can explore a lot in this. I will be writing a simple article as well, which will give a little bit different direction to this video, which will carry, I mean, I will include some details and then I will include some more technical details as well in that. So that's it. Thank you for watching this video, and I will meet you in the next video.